Okay, these are the video notes for the altitudes and orthocenters part of our sequence here. So I'm going to go over some basic notes about what the altitude comes into play here. So we've done circumcenter, which was tied to the perpendicular bisectors. We have done incenters, which were tied to the angle bisectors, and we just came off of the centroid, which were tied to the medians, where the medians intersected. So the orthocenter is going to be related to the intersection of the altitudes. So we have to talk about altitudes here first before we get into what the orthocenter is. An altitude of a triangle is a perpendicular segment from the vertex to the line containing the opposite side. Every triangle has 3 altitudes. An altitude can be inside, outside, or on the triangle. So an altitude is a perpendicular segment. So if I were to look at triangle RQS, okay, the altitude is a perpendicular segment from a vertex to the line containing the opposite side. So here's a vertex Q. This is a perpendicular line to the other side. So this is a 90-degree angle to the opposite side of the vertex. So the altitude is basically that piece right there. These altitudes, this is the height of this base, and this altitude is the height of this base. All right, and then we'll kind of go over what those are as we look into more details with other triangles. All right, so in triangle QRS, altitude QY is inside the triangle, but RX and SZ are not. This is because this is an obtuse triangle. Notice that the lines containing the altitudes are concurrent at point P. This point of the concurrency is the orthocenter. So point P here is the orthocenter, which is this altitude and where this altitude intersect. This altitude SZ is the altitude for base RQ. This altitude QY is the altitude for base RS. All right, and this altitude RX is the altitude for base QS. All right, and so that's where and RX and SZ are outside, but Q, Y, and Y are inside. If this is an acute triangle, all the altitudes will be on the inside, which you'll kind of see coming up. All right. Orthocenters, the altitudes of the triangle are perpendicular lines from each vertex of the triangle to the opposite side. It's also called the height of the triangle. So the altitude is called the height. Height is another word for altitude. A plane with an altitude of 33,000 feet is 33,000 feet above the ground, a height above the ground. So that's where it gets the name from. The 3 altitudes of the triangle are concurrent. That point of concurrency, again, is the orthocenter. All right? So the orthocenter can be inside the triangle, outside the triangle, or on the triangle, depending on the types. The orthocenter is inside on acute triangles. The orthocenter is outside on obtuse angles, and at the vertex of the right angles of a right triangle. Okay? So the 2 examples we'll be doing when we calculate it is going to be, one's going to be an acute triangle, and the other one's going to be an obtuse triangle. That's coming up at the back side of these video notes. All right? The altitude is referenced from the base. If this is the base, this is the altitude. Remember, the altitude runs from the vertex to the base of the opposite side. All right? If this was the base, now here's the opposite vertex that goes from here to this base. This is the altitude for this base. And if I changed to this is the base, this is the altitude referencing to this base. So this is the same triangle, but they have 3 different bases, so they have 3 different altitudes. Where these altitudes intersect is what's called the orthocenter. All right. So again, here is the altitude of a base where you have the base of this segment here. The base has both an acute angle, so the altitude will be on the inside. On this base right here, if I looked at this base, it has an acute triangle right here, an acute angle right here, but this is an obtuse angle, so the altitude is outside the triangle, and mainly because we can't draw from this vertex. I can't draw a perpendicular line anywhere on the inside of this. I have to keep going outside before I reach a perpendicular line. That's why this is on the outside. Secondly, when we reference this as a base, we look at how tall is this triangle. if this is the base? Well, the height of this goes all the way to here, so this is the height, and that's why this is called the altitude from the vertex to an extension of the base is to here at the right angle. So if you look at this, the height of this triangle with this base is up to here. For a 90-degree angle, here's the base, here is the vertex. You draw a line from the vertex, that's a 90-degree angle. In this case, the altitude on a 90-degree or right triangle is the actual other side. So here's a side, here's the hypotenuse. If this side is the base, this will be the altitude. If I flipped it, if this side is the base, this side will be the altitude referencing from this base. All right? If this was the base, the altitude would be something like this. All right? And that's kind of how that works on that end of it. So again, look at the placement in the orthocenter. This is if it's an acute triangle, all the altitudes will intersect and the orthocenter is on the inside. Again, if it's an obtuse triangle, all the altitudes will intersect outside the triangle. And if it's a right triangle, all the altitudes will intersect on the triangle right at that 90-degree angle in the right triangle, all right? And the height of the triangle is the length of the altitude. Okay, so one of the things that we will do is we will go over, I'm going to go over 2 examples on how to solve these for this orthocenter mathematically through these procedures. And I have the procedures up here on the board. And so we're going to find the orthocenter with a triangle with a vertex x, y, and z at these coordinates. And again, these are the steps we're going to go through to make sure that we will solve for the orthocenter. All right, and they are very similar to things we did, steps with centroid and as well as circumcenter. So the first step it says here is graph the triangle. So we're going to have to graph the triangle. So this is x, 4, -1. 4, -1 is right here. Y is at -11 and 4. And z is at -8, -7, which is right here. Those are my points. So you'll take your straight edge. We will, of course, create the sides of these triangles, which is there, and which is here, and it is then here. All right, and then of course I'm going to label this. This is my x, which is 4, -1. This is my y, which is, this is my y, which is -11 and 4. Sorry. -11, 4, and this is z, which is -8, -7. All right. So there's step 1. We graph the triangle, and really how this is going to work with calculating for the orthocenter is we need to get, just like with everything else before, we need to get the equations of the altitude so that we can set them equal to each other, because where they're going to set equal to each other is where that orthocenter will be. So we need to get the slopes of those altitudes, and then we need to get it into y = mx + b format or a slope-intercept format to then set them equal to each other solve. So what does that mean? Well, we have to do this twice. We have to get the slopes of 2. All we need are 2 altitudes to find the intersection point. So we have to run this twice, depending on which sides we choose. Then we've got to do this twice to get the 2 equations, and then we're going to set them equal to each other, and then we're going to graph the altitudes. This is a little bit different. You cannot graph the altitudes until you get the orthocenter first. All right? So I'm going to choose this in green. I'm going to choose x and y and x and z. Okay, so I'm going to choose x and y, x and z. So x, z, x, y, and like we did before, if I'm going to do line xz as my one side and xy as my other side, which one is common? Well, x is going to be the both. So whatever one is common, it's going to be easier to call that x1, y1, which makes these x2, y2, and it makes this x2, y2. All right? And then I'm going to run my slope. I'm going to first run my slope for xy. So we do slope equals, actually we're going to do slope. The slope of xy will equal y2 minus y1 over x2 minus x1. And I will go carefully over to here, and I'm going to go y2 is 4. So I'm going to do 4, put the minus sign in there, minus y1, which is minus negative 1. Okay, so that's y2 minus y1. All right. Minus a negative. We have to make sure to keep track of the signage. All over x2, which is negative 11 minus x1 minus 4. So this is 4 minus a negative 1, which is the same as 4 plus 1. All right? All over negative 11 minus 4. 4 plus 1 is 5. So the slope is, that's going to be 5, and negative 11 minus 4 is negative 15. 5 over negative 15, which is the same as negative 5 over 15. This simplified the slope of xy is equal to negative 1/3. 5 over 15 simplified is 1/3, and then the negative is negative 1/3. All right? I am then going to now get the slope of xz. Okay, so I've got to run this twice. So the slope of xz equals, I'm going to do y2 minus y1. So this is y2. So z to x, y2 is negative 7 minus y1, negative 1. So y2 minus y1, negative 7 minus negative 1, all over x2, which is negative 8 minus 4. So there is y2 minus y1 over x2 minus x1. Minus a negative is a plus. So this is equal to negative 7 plus 6. Negative 8 all over negative 8 minus 4. Sorry, that is negative 7 plus 1. Okay? Negative 7 plus 1 is equal to negative 6. Then negative 8 minus 4 is equal to negative 12. Negative 6 divided by negative 12, this is the same. A negative divided by negative is a positive. All right? And 6 over 12 simplified is 1/2. So the slope of that is, the slope of xz is 1/2. All right? So there is the slope of this line and the slope of this line. And remember, the reason we have to get the slope is we need to get the perpendicular slopes of those, which is what we'll do next, because that'll represent the slope of the altitudes. So if you look at step 3 here, get opposite reciprocal of the slope. So we're going to flip fraction, flip sign, just like we did in circumcenter. So I'm going to go down here, and I'm going to flip, all right? I'm going to flip negative 1 over 3. So 1 over 3 changes to 3 over 1, and negative changes to positive, and 3 over 1 is 3. So the perpendicular slope, so the slope that's perpendicular, and again, this is from x, y, is equal to, all right? So the perpendicular slope for xy is equal to 3. And I'm going to put a box around this. This is the most important slope here. We need to use this. Once I get that, I'm really not concerned with that anymore. I'm not going to use that. I'm going to use this slope for when I run the equation. And the same thing with this one. I'm going to flip 1 over 2 to 2 over 1, and positive changes to negative. So the perpendicular slope for this one is equal to negative 2. All right? So the perpendicular slope for that one is negative 2. I'll put a box around that, and that's why I put it in blue. So the perpendicular slope that runs off of xy is 3. and the perpendicular slope that runs off of xz is -2, all right? Which now leads us into step 4, use the slope intercept to get the b. We did this in centroid, we did this partly in circumcenters in there as well. So we are going to use, all right, we are going to use y equals mx plus b, all right? So y equals mx plus b, all right? This was, put this down here at 1 over 2, which goes to 2 over 1, and make that negative. All right, so I'm going to do it for this one first. So we have the slope. We need an x and a y so we can solve for b. So we need to figure out an x and a y off of this. Notice we didn't do midpoints, but we still have these. So how this works is you're going to have to use the point, the vertex that the altitude runs through. Now we know that if we're looking at x, y, and the altitude is going to run through here, we got that slope of 3, okay? And the altitude has to run through this point. Well, if a point is on that line, we can use it. So we're going to use -8 and -7, knowing that this altitude has to go through this. The shortcut to this is you use the vertex of the letter that is not part of the line. This is x, y, so you're going to use the vertex that's not in there, which in this case is z. So this is x and this is y, and I would go over here and say y is -7 equals, and then my slope is 3 times x, which is -8 plus b. 3 times -8 is -24. -7 equals -24 plus b. We are going to add 24 to both sides. -7 plus 24 is -17 equals b. There is my b. To write, now once you get the b, write the equation of the altitude in y equals mx plus b format. We need to use the slope and the y-intercept. So I need this, and I need my slope to write it, which is this, and I'm going to write it as y equals, my slope is 3, x minus 17. There it is. That is the equation of the altitude that will run from side xy to the z, to the opposite vertex. I then have to do it again with this one from the altitude for xz. So again, I have to use y equals mx plus b, and I'm going to use, if this is the side we use, this altitude is going to go through this point. So I use the vertex opposite of the side. The shortcut, I'm using xz and xyz. If I'm using xz, we go through the letter that we don't have in here. If I've got xz, I'm going to use y. This becomes my x. That becomes my y. So I go over here again, and this slope for xz, the perpendicular slope is -2. That'll go there. So we're going to use y, which is 4 equals, the slope is -2 times x, which is -11. Then it's going to be plus b. -2 times -11 is 22. So 4 equals positive 22 plus b. I'm going to subtract 22 from both sides. 4 minus 22 is -18 equals b. Aha, there it is. I need my b and my slope to write just like the other equation down here. And my equation for the other altitude is y equals -2. There's my slope, -2 x minus 18. That is the equation of my second altitude. There's this altitude tied to xy. This is the equation for the altitude tied to xz. Okay? Now we're back home. So what we do next here is step 5 says set the two altitudes altitude equations equal to each other, solve for x, and then solve for y. So over here, what we are going to do is we are going to set those equations equal to each other. We're going to set 3x minus 17 equal to negative 2x minus 18. That should be correct. Yep. Sorry, this should be negative 7 plus 24. This should be plus, where did that go? This should be plus 17. Sorry. This should be negative 7 plus 24 is plus 17. This should be plus 17. All right. Hopefully many of you caught that as I was doing this. So this is 3x plus 17 equals negative 2x minus 18. All right, so I'm going to get the x's to one side. I'm going to add 2x to both sides. Cancel, cancel. 3x plus 2x is 5x plus 17 equals negative 18. I am going to subtract 17 from both sides. Cancel, cancel. 5x equals negative 35. I'm going to divide by 5. Let's see, let's divide by 5, not negative 5. Divide by 5. Cancel. X equals negative 35 divided by 5 is negative 7. This right here is the x value of our orthocenter. Now we need to get the y, so all we need to do is plug this negative 7 into any one of these two equations. All right, so I'll go and I'll plug this negative 7 into 3x plus 70. So I'm going to use y equals, 3x plus 17. Plug that into here. That equals y equals 3 times negative 7 plus 17. That equals negative 21 plus 17. Y equals negative 4. All right, and that is going to be my y value of my orthocenter. So there's my orthocenter. My orthocenter is going to be at, let's use that one. So the orthocenter is going to be at negative 7, negative 4. Now we can start plotting these altitudes here. So at negative, so I'm going to go to negative 7, negative 4. Right here is my orthocenter. Now, step 6 says we have to graph the altitudes, graph from the vertex through orthocenter to the side. So with our straight edge, and you're going to graph all three altitudes. So I'm going to start with this vertex up here, y. I'm going to go from the vertex through the orthocenter to the side. So this represents right here the altitude. Okay? This is the altitude for base xz. Here's the base, there's the altitude. I'm going to then do it from z, from the vertex through the orthocenter to the side with your straight edge. I'm going to go from the vertex through the orthocenter to the side. That makes a 90-degree angle there. That's an altitude. This is an altitude. This altitude is for base xy. This altitude for base xy. This altitude for base xz. The last one I've got to do is from this one through to here. So again, I'm going to go from the vertex through the orthocenter. Vertex through the orthocenter. That makes a 90 degrees there. That is, this altitude is for base YZ. There, now you can draw all three altitudes, and all three altitudes will meet here at this point. Okay? And there you go. That is how you would graph. That's how you do the math for the orthocenters that are involved with an acute triangle. All right? So the next, as I check, and then I'm going to erase, is I'm going to do this next example. Get all this erased. Okay, so this next one, which is this one right here. Okay, so we're going to go through the same procedure again. I'll go through a little bit quicker, but I'm going to add one thing that you'll do when you encounter an obtuse triangle. And we're going to have to graph this thing here first. So this is -10, -2, which is here. 2, 2, which is here, and 4, 12, which is right up here. Okay, so now we draw the sides of the triangle, which is this, which is this, and which is this. All right, and then we're going to label this. This is x, which is -10, -2. This is z up here, so I'm going to mark this as z, which is 4, 12. And this is y, which I'll put right here. Y is then 2, 2. All right? Okay? And then we have to ask ourselves, is this the right triangle? Is this an acute triangle? Or is this an obtuse triangle? And so we can look, this is an acute angle, this is an acute angle, but when we look at this one here, we realize this is over 90, this is an obtuse angle. So if there's an obtuse angle in the triangle, it is an obtuse triangle. Now, once you identify this as an obtuse triangle, before we start, we're going to extend the bases of the two sides that make up the obtuse angle. These two sides make up this obtuse angle, so we're going to extend those lines. It's going to help us graph an understanding that since this is an obtuse angle, the orthocenter is going to be outside of the triangle this time. Somewhere outside, probably somewhere down here. So what we do is, before we start our calculations, you are going to extend the bases of the two sides that make up the obtuse angle. So here, this is in green. I'm going to, and you use dashed lines, I'm going to extend these somewhat far out, okay? Because we know this is the base, the altitude has to go up over here, so the altitude is probably going to have to meet up in this way some way. Then I have to extend this base, okay? This base right here does this. I'm going to extend it in this direction, okay? And then, now we're going to start our calculations. These lines are going to help us graph the altitude at the very end. But you want to do it at the start, so it gives you an idea. Once you get here and here, we know that our circumcenter is going to be trapped somewhere in here. That's also going to help you give an idea of a general area where that's going to be. So just like the last problem, we're going to go through these where you get the slope of two sides. All right? So we're going to do, let's see here, we're going to do xz, and then we're also going to do xy. So we're going to do xz and xy. X will be the common then. So if x is common to both, so xz, xy, so that's going to make this x1, y1, it'll make these x2, y2, x2, y2, and I'm going to run my slopes. I'm going to do xy first. So the slope of xy equals y2 minus y1 over x2 minus x1. All right, so then I'm going to run through here from xy. y2 is 2 minus negative 2 all over 2 minus negative 10. This is not 2 minus 2, this is 2 minus negative 2, and it's also 2 minus negative 10. That switches both of them to 2 plus 2, and then this is also going to be 2 plus 10. 2 plus 2 is 4. 2 plus 10 is 12. 4 over 12 simplifies. The slope of xy is equal to 1/3. Okay? We'll do the opposite reciprocal here in a second. So there is my slope of xy. Now I'm going to get the slope of xz. All right? The slope of xz. So again, I'm going to do the slope of xz using y2 minus y1 over x2 minus x1. All right? And so here we go. Y2 is 12. So this is going to be 12, right, the minus. 12 minus negative 2. Again, not 12 minus 2, 12 minus negative 2. All over x2, which is 4 minus negative 10. 4 minus negative 10. Again, two opposite pluses. Negatives changes these to positives. So that's 12 plus 2. 4 plus 10. 12 plus 2 is 14. 4 plus 10 is 14. 14 over 14 is 1. So the slope of xz equals 1. All right? Now what I've got to do is get my opposite reciprocal of both. All right? So again, I'm going to flip the fraction, flip the sign. When I flip this fraction, 1 over 3 becomes 3 over 1. This is positive, this is negative. So my perpendicular slope is equal to negative 3. I'm going to box that. Once I get that, I really don't have any use anymore for that because I need to use the slope of the perpendicular line. I'm going to flip this. So this is 1 over 1. We flip 1 over 1 to 1 over 1. Opposite is negative. So clearly the opposite reciprocal of 1 is negative 1, which everybody should know. So that slope of that perpendicular slope equals negative 1. All right? So now, what we will do is, again, I'm going to box this in because I want to make sure I use that. We're not going to have any need for that anymore. All right, so now I've got the slopes. Now I need to go get the equations in y equal mx plus b. So I need to go run this twice using both of these slopes. So again, I'm going to do y equals mx plus b. And since I'm doing xy, okay, xy is the base I'm using. So the x and y from what I'm going to use here, I've got this as the slope, which is here. I need an x and a y. So I need to use where the altitude, and this is the opposite side, so the altitude is going to go through that. If I'm using x, y, you use the point of the letter that you don't use. In this case, this is z. This is going to be x and y, since this is the opposite vertex. So I'm going to write 12 is y equals this slope, since it's tied to that, this is tied to that. This is going to be negative 3 times x, which is 4, plus b. Negative 3 times 4 is negative 12. 12 equals negative 12 plus b. I'm going to add 12 to both sides. Cancel, cancel. 24 equals b. So now I'm able to write, there's my b, there's my slope. All right, y equals my slope, negative 3x plus 24. Okay, that is the equation of the altitude that will go through, from here, that will go through this base. I then have to do it for the other one, xz, all right? So again, y equals mx plus b, and if I'm using x and z as my side, I use the vertex opposite the side, all right? So and also, it's not in something. If you're using x and z, it's whatever the point is that's not on the line here, the references line. So if it's xz, I must use y. That makes this x, and that makes that y. And I'm going to do, and we're going to use this slope this time. So y is equal to 2 equals negative 1 times x, which is 2, plus b. Negative 1 times 2 is negative 2. 2 equals negative 2 plus b. All right? 2 equals negative 2 plus b. I'm going to add 2 to both sides. 2 plus 2 is 4. 4 equals b. So there we go. I've got my b, and I've got my slope. So the equation of that one is going to be y equals negative 1x, okay, plus 4. Or negative x plus 4. There is the 2 equations of the altitudes, which now once I get to that, okay, set the 2 altitude equations equal to each other and solve for x. So I am going to set these 2 equal to each other. Negative 3x plus 24 equals negative 1x plus 4. Okay, I'm going to move the smaller one. I'm going to add 3x to both sides. Get the x to one side. Okay, cancel, cancel. This is 24 equals negative 1 plus 3 is 2. So that's 2x plus 4. I'm going to subtract 4 from both sides. 24 minus 4 is 20. 20 equals 2x. I'm going to divide by 2. Divide by 2, divide by 2. That means 10 equals x. That is the x value of my orthocenter. So now all I need to do is plug this into one of these, and it will solve for the y. So I'm going to take this 10, let's plug it into here. We're going to plug it into y equals negative 1x plus 4. That goes into here. Y equals negative 1 times 10 plus 4. Negative 1 times 10 is negative 10 plus 4. Y equals negative 6. That is my y value. So now we know, we will know that my orthocenter is at 10, negative 6. So I'm going to go, now I can graph my orthocenter. It's at 10, negative 6, which is down here. So 10, negative 6. There is my orthocenter. And as you can see, it is outside of the triangle. Now this is where our extensions of our base come into play, because we've got to graph the altitudes. And we're going to graph graph from the vertex through the orthocenter to the side. Now through doesn't mean you necessarily have to go in that order. We have to go start from the vertex. We can go through an orthocenter here where the side is here. You're going to have to use this as an anchor point here. All right. I'm going to start with y here, and I'm going to start at the vertex. Okay. I'm going to have to go through the orthocenter. Okay, but going through means I don't go necessarily this way, and I have to the side. Well, if I went this way, I'm not going to run into a side, but we do know that this altitude that's tied to this goes to here. So once I get this lined up, this becomes a solid line, but then you're going to continue with the dashed line all the way down to the orthocenter, so it's reference. You do not make this a solid line, because the solid line represents the altitude. So this is the altitude. That is the altitude from base xz. Now we've got to do z and x. And again, we're going to graph the altitudes, graph from the vertex through the orthocenter to the side. All right? So I'm going to erase probably the coordinate references here. Let me get rid of these. You do know that that's y. We'll leave that there. All right? So for z, I'm going to go from the vertex, line up through the orthocenter. So I'm going to start at the vertex. I'm going to go through the orthocenter, but I have to stop when I get to the other side. This is an extension of that base. So I'm going to draw it until I get to that dashed line that represents the base. Then I got to stop, but then I'm going to continue with the dashed line that goes to the orthocenter. This is the altitude for base x, y. This is the base. This is the altitude for this. Then I've got to do it for this last one here. Same thing. I'm going to go from the vertex x through the orthocenter, finishing at the side. So I start at the vertex. I'm going to keep going solid line, which will represent until I get to the extension of that base. Then I continue with a dashed line through to the orthocenter. This is the altitude. All these are altitude. This is the altitude for base zy. This is the height for the triangle from this base. All right? So there you go. We have solved for the orthocenter and all three altitudes for this. All right? And that concludes A, the notes, and B, two examples. One an acute triangle, and the second one an obtuse triangle. And that'll give you an idea how to do those. Use these as an example. That is it for these video notes. Continue on to the worksheet 1 and the additional problems that you will need to do.